Welcome back to my math teaching online today. In this video, I will talk about the application of antiderivative. Um, in the first course, we use a derivative to apply and find out to solve the problem. Now we use the antiderivative. So everything about the application to our real life problem. When I design most of my mathematics courses, I follow the protocols of simplicity, practical, and logic, and conceptual. So there's a lot of application problem in my math courses um, because I found it's interesting and it's very practical. It's apply the theory to solve the problem. Anyway, let me get right into the question. Let me read the question out loud to you. So a canister is dropped from a helicopter 500 meters above the ground. Unfortunately, its parachute does not open. It has been designed to withstand an impact velocity of 100 meters per second. Will it burst or not? Okay, so how do we answer this question? Let me summarize the scenario. So we have a helicopter drop a canister from the height of 500 meters to the ground. Now, why do we have a negative? Because just in math and in physics, for convenience, we assign the convention is downward is negative and upward is positive. Which is the convention. Now you can assign, you can change as well. You can say up is negative and down is positive. Doesn't matter. But as long as you're consistent, right, with the data information. Okay, so let me get back to here. So we know that this canister is dropped. When the word say is dropped, it implies that its initial velocity V0 here stands for initial velocity equals 0 meter per second. So if you don't toss the object to the sky or throw it very strong to the ground, then you just drop like this, initial velocity will be 0. When the object fall down, it was pulled by the force of gravity of the earth. And that force of gravity pulled every object from an apple to a textbook to a helicopter. Doesn't matter big or small, heavy or light, right? So the force of gravity, which is the force from the center of the earth, pull out any object as long as it's still in the orbits of the earth, right? Not outside the in the universe, out of escape the velocity, right? But we're talking about whatever on the earth's surface. So to find out the answer for this question, the question say, so this canister will be found out to the ground, will it be broken? Because the parachute does not open to make it like fall slightly, right? But it fall very fast because due to the force of gravity. So when it hit the ground, is it broken or is okay, right? So how do we know that? We will know if we find out the final velocity of the canister, right? We know the initial velocity is 0 because it will drop from the helicopter, but we don't know the final velocity. So if we find out its final velocity is less than 100 meters per second, then it will be okay. It will be safe to be sure that this canister is not broken, it's not burst, right? Okay, so how do we figure it out? Let's see. We know that the acceleration towards the Earth is minus 9.8 meters per second square. This is acceptable for all the object, right? But what is the acceleration of this object when it falls down? This acceleration actually is the velocity of this object, but the velocity here is the rate of change, right? Which is the v grind. So this A here equals v grind t. And it equals minus 9.8 meter per second square. So we can do the integration of the v grind t. If we do the integration of v grind t, what do we get? We get to the vt, right? And integration of v grind t, which is the integration of minus 9.8 dt, right? So this will give us minus 9.8 t plus c. So that's the antiderivative we was practicing before. We know how to do antiderivative. So that's minus 9.8 t plus c. Now, what else we figured out? We want to figure out what c is equal, right? So how do we figure out c? This is the vt, right? And we are given the initial velocity equals 0. So we can set this equation equals 0. Minus 9.8 t plus c equals 0. Because we know its velocity at the beginning is 0, right? So now if we substitute v0, we got minus 9.8 times 0 plus c equals 0. That tells us the c here also equals 0. So now we have an equation of Vt equal minus 9.8 t back into the equation plus c, but the c is 0, so we don't need to state the c it here. So what else we can do? What else we have the information? We know that the height from here to here is minus 500 meters, right? So we're talking about the height. We want to find out what the height function is. Fortunately, the height function here is the same like the position function, right? But we're talking about the height. So I change the s become h. So the height respect to the time. And to get this, we have to do the integration of Vt. If we do the integration of Vt, velocity, we get to the position function, right? So the height respect to time equal in integration of velocity. And that equal to the integration of minus 9.8 integration minus 9.8 t, right? And that will be equal, so therefore the height of t will be equal minus 9.8 divided by 2 t squared plus c. Okay, so actually height of t equal minus 9.8 t squared plus c, yeah. And that height of t will be equal minus 4.9 t squared, right? 9.8 divided by 2 equal minus 4.9 t squared. But do we know the height here? Yes, we know, right? We know this height equal 500, minus 500. So if we figured out how long does it take for this canister travel from the helicopter down to the ground, then we can figure out something about final velocity, right? So let's solve this equation. They both negative, so now we can change both of them become positive. So 4.9 t squared equals 500. Therefore, t squared equals 500 divided by 4.9. And our t squared will be equal 102 second. So take this, therefore t, we take the square root 102 second, we get 10.1 second. So it takes 10.1 second for the canister from down to the route. How do we figure out the final velocity? Back to the function of velocity. So we have the function of velocity equal what? Function of velocity equal minus 9.8 t. So now Vf, right? Vf of t, and our t is 10.1 second. It takes 10.1 second for the object from down to the round. So will be minus 9.8 times with 10.1, and that will give you, let me get the accurate. It's round up the same like 9.8, but this is about 99 meters per second. So that is the V final of this object. So what is the conclusion? The conclusion that the canister will not be burst. Will not be burst. That's how we answer this question. So I have another question here similar to this question. I want to go over with you quickly, but maybe I should show it in the next video. So let me end the video here, and I hope you enjoy my video and understand this problem. So let me summarize a little bit, right? So we have a canister have initial velocity 0 because we know it is dropped, right? And we know at the time 0 at the beginning, its height is also equal 0. Now we know the acceleration of any object from down is minus 9.8 meters per second square. And that is the acceleration. So the same like v prime, the rate of change of velocity of this object. If we integrate the rate of change of v prime t, we get back to, we go backward, we get velocity of the object respect to time. So we want to find out the final velocity. And to find out final velocity, we have to apply the time, how long does it take? We multiply with the, for final velocity, right? We want to find out Vt. If we have a function of Vt, we can substitute the t to find out the v, right, velocity. So we know that Vt equal minus 9.8 t plus c equals 0 because at the time 0, this object is 0, velocity is 0. So we set this velocity equals 0. We find out the c here. Now, when we set this, we find out the c equals 0. So we know the function of this velocity is Vt equal minus 9.8 t. Now, we also know that if we integrate the Vt, we get back to the position function, which is how high this object is, right? At any level, how high it is when it forms. So the height respect to the time equal integration of the velocity Vt, which is equal the integration of minus 9.8 t. So we do the integration, we get the height with respect to time equal 4.9 t squared. and we solve, we get the t equal 10.1 second. Now, when we get the t, we know that this take 10.1 second for this canister hit the ground. We plug that 10.1 back into the velocity of t to find out the final velocity. And the final velocity equal minus 99 meters per second. Then we compare with this number they give us. They say this canister withstand an impact velocity of 100 meters per second. So if how fast it go, if it go over 100 meters per second, it goes too fast, it hit the ground, it bursts. But if it's less than 100 meters per second, which is just dry about, right, minus 99 meters per second, so we know that the canister is safe. So that is about the video today I was explaining to you. So thank you for watching my video. I hope you enjoy, and I will see you in the next video, probably tomorrow. So see you tomorrow. Bye for now.